Kirchoffs Law. In a compound circuit, a junction, as indicated here in red, is a spot where the current splits and then comes back together. You could see, for example, if you had 10 currents traveling this way, this spot, it would have a choice. And you could have, for example, 3 and 7 go down each branch. Then they would re-meet back up at the junction and then split again. Branch is a path that connects the two junctions. Each branch will have the same voltage. Those are indicated here in green. Let's do some sample problems so that we can understand what this law means. This is an example of a compound circuit that has a junction and 2 branches. Compound circuits will contain both series and parallel elements. You can see that this, for example, is in series, that this portion is in parallel. To find the total resistance in a circuit, you'll have to simplify it into smaller components. And we'll do that by finding what's called the equivalent resistance. So what we're going to do is we're going to simplify this down into its equivalent resistance. So that we're essentially going to create a circuit that looks like this, with this being 1 ohm, and then this resistor right here being the combination of these two. So let's find the total equivalent resistance of these two. 1/3 plus 1/6. That would be, what is that? 3/6 or 1/2. So its total resistance would be 2. You can see that these two now have been simplified into a single resistor, and that single resistor is now in series with this guy right here. So our next step is to simplify this down into just like a single resistor with the equivalent resistance of all 3 of them. Since this is in series, it would be adding them together, 1 plus 2, so the total resistance would be 3 ohms. If you wanted to, you could take it one step farther and you could say, all right, I know that the total voltage is 12 volts. The total resistance is 3 ohms. You could use this to use V equals IR to find the total current. And you could say, all right, well, the total current is going to be 4 amps. Let's explore a different set of compound circuits. Each of the light bulbs in these 3 circuit diagrams below has a resistance of 1 ohm. What's the total circuit resistance and current for each circuit? Let's start with this one. This is a circuit in series. So if each of these are 1, we can add together 1, 2, 3, 4, 5. The total resistance would be equal to, oops, I'll do that in black, 1 plus 1 plus 1 plus 1 plus 1, which is a total resistance of 5. So the total voltage is 9, the total resistance is 5. We can use V equals IR to find the total current, which would be 9/5, or 1.8. All right, let's check out this next one. This next one has 5 light bulbs as well, 5 resistors. So if we calculate our equivalent resistance, 1/1 plus 1/1 plus 1/1 plus 1/1 plus 1/1. 1/R equals 5, which means that R is 1/5, or 0.2. So this has a total voltage of 1.5, a total resistance of 0.2. We can use V equals IR to find its total current, 7.5. This last one is interesting because this last one is a complex circuit. Let's take a look at how we can simplify it. I think my first step to simplify it would be to take these two together and combine them into 1. Since these two are in series, 1 plus 1 together, they have 2 ohms. So if we are looking at the total resistance of the circuit, now that those two have been combined together, you can imagine that these are now in parallel. We can say that's equal to 1/2 plus 1/1 plus 1/1, giving us 2.5 with a total resistance being 0.4 ohms. And we can use V equals IR to find the total current, 7.5. I find it interesting that these two both have a current of 7.5, even though this has way more resistors, because this has one complex circuit and this one doesn't. Let's take a look at one more example. It says calculate the following for the circuit shown. Here is the total voltage, 120 volts. I'm going to start by calculating the total equivalent resistance. And I'm going to first explore the idea that we can combine these two together and simplify our circuit into something that looks like this. This being the 80 guy over here, and this being whatever we simplify those into over there. So let me do that. 1/100 plus 1/50. That gives us 33.3. So our next step is going to be to take this circuit and simplify it into something even more basic. So since this is in series now, the total resistance is going to be 80 plus 33.3, 113.3. So this voltage right here is 120. We know the resistance is 113.3. We can use V equals IR to find the total current. 120 divided by 113.3, 1.06. Perfect. All right. So that means that as we explore this circuit, that we can imagine that as charges leave this battery and travel through, that there are a total of 1.06 amps. That means that these two right here together get 1.06 amps, and that this guy gets 1.06 amps. So I'm going to label that right here before we get any farther, 1.06. And these two right here, I'm going to make myself a little note. These two are going to share 1.06 amps. Viewing this as a puzzle, I see that I can now solve for the voltage right here. So using V equals IR, I'll do 1.06 times 80. That'll give me the voltage at this spot right here, which is 84.7 volts. Knowing that this right here has 84.7 volts, that means that the total 120 has been decreased by 84.7 volts, and that this voltage right here is going to be equal to 120 minus 84.7. You can see that these two right here are both 35.3, that they don't split that voltage up amongst each other, because if there are 35.3 volts coming out of here, then each of these would receive those full voltages, because coming out of this end, going into this end, they would each have the same voltage. And that this plus this equals 120. Now that we know that, we can do V equals IR to find our current. If we did this right, they should share 1.06 amps of current. Let's check it out. 35.3 divided by 100 is 0.353. 35.3 divided by 50 is 0.706. We can check our work. 3.53 plus 0.706 gives me 1.06 amps. There we go. We have solved it. And in solving it, we've also supported Kirchoffs Laws, which says that each one of these branches has the same voltage and that the current splits upon reaching a branch right here, and that you can see that the current splits and that each will share that total current.